What if I told you that the future of computing might be growing in your backyard, or maybe even on your pizza? It's true! Scientists are looking at something amazing. They are looking at mushrooms. Yes, the same fungi you see in the forest or in the grocery store. It turns out these fantastic fungi can do more than just taste good in a salad. They might just be the key to building the next generation of computers. Imagine a computer chip that isn't made in a factory. Imagine a chip that grows from the earth itself. This isn't science fiction. This is science happening right now, today, on October 28th, 2025. It's pretty cool. Consider this. So, how does it work? How can a simple mushroom act like a powerful computer chip? Researchers at The Ohio State University made a huge discovery. They found that mushrooms can store information. They can remember things. Think of it like a light switch. You can flip it on or off. A mushroom can do something similar with electricity. When you send a small electrical pulse into the mushroom's network of threads, called mycelium, something incredible happens. The mushroom changes. It changes how it responds to electricity. It holds on to that change, which is a form of memory. It's like the mushroom is saying, I remember that spark. This process is a lot like how our own brains work. Inside our heads, we have billions of tiny cells called neurons. When we learn something new, the connections between our neurons get stronger. This is how we form memories. The mushroom's mycelium network does something very similar. When it receives an electrical signal, the connections in its network change. This ability to change and remember is what makes it a memory store, a memory resistor. It's a living, breathing piece of hardware that learns from experience, just like us. It's an organic brain that we can use to store data. It's nature's own hard drive. This is a huge deal. For decades, we have relied on silicon and metal to build our computers. We dig these materials out of the ground. We process them in giant, energy-hungry factories. It's a complex and expensive process. But mushrooms, they grow all on their own. They can grow on simple things like hay or wheat germ. We don't need a massive, polluting factory to create them. We just need a little bit of compost and some patience. This opens up a whole new world of possibilities for creating electronics that are in harmony with our planet. A world where our technology grows just like a plant in a garden. Let's compare the old with the new. On one side, we have our traditional computer chips. They are made of silicon. They are incredibly fast and powerful, no doubt about it. They have powered our world for more than half a century. But they come with a cost. Making them requires a lot of energy. It requires rare minerals that are hard to find, and when we're done with them, they become electronic waste. This e-waste is a huge problem for our environment. It piles up in landfills and can release harmful chemicals into the soil and water. It's a challenge we have to solve. Now let's look at the mushroom chip. Consider the shiitake mushroom. It's a completely different story. Instead of being mined, it's grown. It's a renewable resource. It doesn't need a high-tech, sterile factory. It just needs organic material to grow on. And the best part, when you are done with a mushroom chip, it's biodegradable. That means it can break down naturally and return to the earth without causing any harm. It's a closed-loop system. We grow it, we use it, and it returns to nature. This is a huge step forward for creating sustainable technology. It's a way to have our gadgets and protect our planet too. There's another big difference: energy. Your computer, your phone, all your devices are constantly using power. Even when they are just sitting there, they are sipping electricity. Silicon chips need a constant flow of energy to hold on to their information. But mushroom chips are different. They are incredibly energy efficient. They use much, much less power, especially when they are in standby mode, because their memory is based on a physical change in the mushroom's structure. They don't need constant power to remember. This could lead to devices with batteries that last for weeks or even months. And what about performance? Can a humble fungus really compete with a high-tech silicon chip? Well, the latest research is very promising. Scientists have shown that these fungal memory stores can switch their states thousands of times every second. They have an accuracy of up to 90%. While they are not as fast as silicon yet, especially for complex calculations, they excel at certain tasks. They work best at low frequencies, similar to the rhythm of our own brains. By linking many mushroom disks together, their performance gets even better. It's the beginning of a whole new way to think about processing information. Think about the places where we need computers. We use them everywhere, from our comfortable homes to the most extreme environments you can imagine. We send computers into deep space. We put them at the bottom of the ocean. We use them in deserts and in the frozen Arctic. But our regular electronics are delicate. They are very sensitive to things like radiation, extreme temperatures, and physical stress. A blast of cosmic rays in space can scramble a silicon chip's memory, causing a catastrophic failure. This is a big problem for missions to other planets or for satellites orbiting Earth. This is where our fungal friend, the mushroom, really shines. Mushrooms are natural survivors. They have evolved over millions of years to withstand all kinds of harsh conditions. Shiitake mushrooms, for example, contain a special compound called lentinan. This amazing substance acts like a natural shield. It protects the mushroom's cells from all sorts of dangers. It can handle radiation, big swings in temperature, and even damage from UV light. A computer chip made from a mushroom would have this incredible durability built right in. It would be a rugged, resilient piece of technology. Imagine a satellite powered by fungal circuits. It could travel through the harsh radiation belts of space without needing heavy, expensive shielding. Or think about sensors dropped into a volcano or deep sea vent. A regular chip would be fried in an instant. But a mushroom-based circuit could potentially survive and keep sending back valuable data. And here's something truly mind-blowing. If a mushroom chip dries out and stops working, you might be able to bring it back to life. How? By just adding a little bit of water. It can rehydrate and start working again. Try doing that with your smartphone. This natural resilience makes fungal electronics perfect for a whole range of applications. They could be used in soft robotics, creating robots that are flexible and can withstand being bent or squeezed. They could be woven into smart clothing that monitors your health. Because they are so tough and lightweight, they are ideal for wearable technology. The possibilities are truly exciting. We are just beginning to understand how we can use nature's own survival strategies to build better, stronger, and more reliable technology for the future. It's a powerful partnership between biology and engineering. So, what does this all mean for our future? It means we are on the verge of a technological revolution, a revolution that is green, sustainable, and alive. For the first time, we can imagine a world where our computers are not just cold, lifeless boxes of metal and plastic. We can imagine computers that are living organisms, devices that grow, learn, and eventually return to the Earth, completing a beautiful, natural cycle. This is a profound shift in how we think about technology and our relationship with the natural world. It's a future where innovation and environmental responsibility go hand in hand. One of the most exciting things about this new technology is how accessible it is. You don't need a billion-dollar laboratory to experiment with fungal electronics. According to the scientist leading this research, you could start exploring this field with some very simple materials. We're talking about a compost heap and some basic homemade electronics. This means students, hobbyists, and citizen scientists all over the world can get involved. They can grow their own mushroom circuits. They can run their own experiments. This open accessibility could accelerate research and lead to new breakthroughs we can't even imagine yet. Think about it. A future where your computer is not just a tool, but a partner. A living system that works with you. A computer that can heal itself, adapt to its environment, and operate on very little power. We could have buildings with walls that act as giant, living computer networks, monitoring the structure's health and environment. We could have medical implants that are fully biological and integrate seamlessly with our bodies. We are moving from a world of manufactured machines to a world of cultivated systems. It's a change that could redefine what it means to be high-tech. This is more than just a cool science experiment, it is a source of hope. It shows us that we can find solutions to some of our biggest challenges, like e-waste and energy consumption, by looking to nature. The answers are all around us, in the soil, in the forests, in the amazing biology of a simple mushroom. The future of computing could be organic, biodegradable, and full of life. It's an inspiring vision, and it's a reminder that when we work with nature, instead of against it, anything is possible. The future is fungi, and I, for one, am very excited to see it grow. Consider that